안녕하세요. 저는 오늘 아침에 미국에서 온 강정석입니다. 근데 제가 이 강의를 한국어로 해본 적이 없어서 미리 죄송하고 부끄럽게도 영어로 진행하겠다고 말씀드리고 싶습니다. Yeah, I just finished my PhD at Harvard in applied physics, and then I studied neuroscience and AI. And currently I'm starting a research group out of MIT Midiorep, as well as working with MIT leadership on studying AI and ethical implications regarding AI technologies. And I'm going to be talking about AI augmented human intelligence based on my PhD research, as well as what I'm currently doing, as well as pursuing as a whole at MIT. So we talk about human intelligence quite extensively today, because I personally believe that a lot of the AI technologies that are deployed in industry and society right now are meeting its limitations. Because a lot of the AI models that we're creating take in raw data and we segment them or annotate them with human expertise and then be able to construct models. And these are inherently biased towards what we already know about the world or what humans already understand about the world. Whereas ultimately, when we want to be able to mimic human intelligence, we want to be able to create something completely new, like human beings can do with their creativity, or be able to think about abstract thoughts and be able to learn completely new things or reason that machines cannot usually do right now. So my PhD research was largely on understanding human intelligence from both molecular perspectives by studying atom by atom of the human brain, as well as studying observational traits of intelligence, as we can tell from psychological experiments. So let's take a look at, before we go into understanding this grand challenge of understanding the human brain, I want to give you a perspective on how difficult and super challenging it is to be able to understand any type of neural network or neural system in general. So what you see here right now is C. elegans. It's a small worm with 302 neurons. And people literally did spend 20 years, or actually more than 20 years, slicing these worms, slice by slice at 100 nanometer scale, and then put them on a tape and took the images of each slice with electron microscopy and hand traced every single one of the polygons you see on the images with a marker. And it took them a decade or two to be able to reconstruct this entire thing. And then currently, this is how we study the brain or neural networks in general as well. Like, only improvement we made is that instead of using a marker, we use computerized system. And a lot of the people in medical industry also do this for radiation therapy training or planning. And it took them, after we gained all the data, it took another 8 years to reconstruct them in silico, inside the computer. And the advantage of doing that, and then why people did this to begin with, is to be able to study the fundamentals of how neurons communicate with each other and be able to really think about, can we actually improve an animal being or a neural network as seen in nature in silico inside the computer and accelerate evolution and be able to put them back in real life beings. And that was another grand challenge. And then this way we were able to understand how presynaptic, postsynaptic neurons communicate with each other through chemicals, and then really was the early founding father of a lot of the fundamentals we know about how neurons communicate and work and improve and etc., which later became early, I guess, blueprint of what we call neural networks. And it took them like 8 years to reconstruct this, but it was worth it for the person who initiated this project because he won a Nobel Prize. But also at the same time, what we ended up getting after spending billions of dollars was neural network of a worm. And it was highly useless in terms of how it improves, human health or human intelligence in general. So since then, people spent, because the human brain has 86 billion neurons, unlike 300 neurons in the worm. And since then, people have spent billions of dollars and decades being able to mimic what we did for the worm, for the human brain. And even after technological advancements we had, it's still taking forever for us to reach there. And Brain Initiative, for example, is a government-initiated initiative started by Obama administration. And Allen Institute is Paul Allen, the billionaire's money being put into this research, like $1 or $2 billion every year. But still, we are really at the tip of the iceberg in terms of understanding how the brain works. And I don't even know if we know what the tip looks like. You know, it's a dauntingly just enormous amount of effort that was put in, but still we don't have complete understanding or even like remote understanding of how the brain works, as evidenced by a recent stock price drop in Bayer in Alzheimer's therapeutics failure, for example, or like how people think about depression or schizophrenia or multiple other things, and then let alone trying to deduce or reduce what we understand about this vague understanding of the brain towards AI development. So, and then during my PhD, what I tried to do was that I really honed in on attempting to understand how creativity works. Because creativity, to me at least, is like uniquely what we call a human behavior or human intelligence. And then it's extremely hard to mimic that into reducible formula or mathematical equations. And yeah, I mean, there's really no clear way to define creativity. It's an extremely daunting philosophical challenge, and I did not attempt to really win it during my PhD timeline. But at the same time, I was attempting to look at how, when people are trying to solve a task using creativity, I would look at their fMRI images and see which part of the brains light up, and then actually study those parts using electron microscope, and then look at molecular aspects of it, and then also take an observational approach to building creativity AI model. And then it was just impossible, you know. This is my favorite example regarding what I call creativity. Those 4 equations are called Maxwell's equations, and those define electromagnetic equations that we still use today to be able to build Wi-Fi or microwaves and everything. And those are the 4 fundamental equations that have been, you know, unchangingly used every day in this field. And when Maxwell, the scientist, first conceived the idea and then attempted to make these equations, he didn't know that much math. He literally imagined how electromagnetic waves would look like in thin air, and literally imagined how Wi-Fi, or not, he didn't have Wi-Fi back in the day, but how sun rays or all these electromagnetic waves that are not visible to us would look like in mathematical terms, and then attempted to draw them out. He literally hand drew these spheres and waves that he would imagine. And then people later invented mathematics to be able to understand what he did. So he literally saw something that no one ever can conceive or imagine in thin air. And this is a type of creativity I attempted to understand and be able to mimic in AI system. And these are some of the people that I come across during my research, or my colleagues. Sal Perlmutter is a Nobel laureate in physics. He thought about how to measure how universe expansion is actually accelerating by looking at relative positions of satellites between them together, and then explaining them in a multidimensional fashion. I mean, that's just seriously, you know, no one can think of it that way or be able to really think about how to even measure or anything like that. And my favorite example is this person called George Church. He's a professor at Harvard Medical School. And what he did was that he's a biologist, but he realized that our current data storage system involving zeros and ones, 2-bit system, are really limiting, because like we have massive data warehouses that are overloading with too much data right now. And then he realized that, look, DNAs are actually extremely effective at storing data because they have 4 bits, because DNA has ATGC. So he decided to use DNA as a data storage platform, and then he sold his company to Microsoft, and they're currently working on turning all their warehouse data into DNA. And then the example you see here at the far right is that he managed to store entire Washington Library books, which is the biggest library in the US, into that small volume of DNA. And this sort of creativity, how do we even mimic? And then my work largely involved, I mean, I cannot take brains out of these professors and try to study them. So a lot of my work involved interviewing them and then trying to take observational information on what I think is a way to create creativity. And, oh, yeah, and then I didn't know it was translated. Yeah, but currently the AI system largely has takes raw data and creates algorithm around it, and then goes through trials and errors to be able to perfect the system over time. And then hopefully you get some out of it. And then this is I think, this way of approaching human creativity and trying to mimic the AI system is fundamentally wrong. And I think this calls for a new challenge to be able to think about how we think about AI creation to be able to accommodate that. And there are other examples of AI creativity already out there. Like Google has worked on Magenta project where they tried to create music or ING has also created artworks using AI. And then these are usually really impressive, but at the same time, at the end of the day, all they're doing is really mimicking. And then this really doesn't call for innately human creativity that AI can mimic. But taking a step back, I'm not here to talk about my PhD research too extensively. And then, so to give you a short answer, attempting to create human creativity using AI is a work in progress and that I'm still working on. And then what really caught my eye was that recently people have been working on taking a different route to utilizing human creativity as opposed to copying them or trying to mimic them using artificial intelligence system. They started thinking about, can we actually integrate existing hardware we have right now and software we have right now into existing human beings, and then actually give AI superpower to human beings so that we can actually utilize human creativity itself, but supercharge them with computational methods or AI techniques that we can actually utilize. So I'm going to be talking about how some of the examples of AI augmented human intelligence, basically. And then a lot of these works are, I wished I was going to talk about some of the more confidential work that are happening in research labs, but I think it's broadcasted, so I don't think I can talk about this. So I'm only talking about industry examples today here, but I'm more than happy to talk more about what's the current state of research is after this lecture if you're interested. But yeah, the very first form of AI augmented human intelligence is a work done by Halo Neuroscience, or I mean, their technology is, I wouldn't say extremely different from earlier versions of brain-machine interfaces that we've seen before. But what basically do is that they package it into a really useful consumable so that a lot more people can adopt it. And what they do is that they measure brain waves through the skulls using that headphone-looking device, and then try to measure which part of the brains are lighting up when people are playing music, or which parts of the brain are lighting up when people are working out or doing sports. And then they try to augment it by, if this person was playing music and then these 4 regions of the brain lit up, that means that if the person who's playing less perfection in music without these 4 regions lighting up, then maybe we can give electro excitement towards one of the regions that is not lighting up to be able to augment this human's capability. I don't think it's a scientifically proven work yet, but it's a work in progress, and then they're collecting massive amounts of data to be able to do that. And then, of course, one of the biggest examples is Elon Musk's recently introduced Neuralink. And what he does is that instead of reading out brain signals through the skull, he managed to actually implant microchips inside the skull so that you can get a better spatial temporal resolution and be able to, again, his hypothesis is that this will allow him to gain better access to the brain so that we can actually have a brain communicating with the computer. But at the same time, well, he did an impressive job at making this machine that can put in chips inside the brain that is connected to smartphones. But at the same time, this goes back to the same argument or challenge that I talked about. Like, we don't understand the brain at all, like, let alone, like, how do we know which chips to put in where to be able to actually augment human intelligence? So he is accepting patients who are, I guess, terminally ill patients to start with, but I don't think this is the right approach, at least, to begin with. And yeah, I've been also talking to Facebook a lot, some of the researchers at Facebook a lot, because Facebook is working on telepathy research, be able to communicate from brain to brain or brain to human, smartphone to brain. And then I can only talk about what's been publicly disclosed, and then what they basically do is that they basically made a better version of how we read out signals from the human brain to be able to translate that to text-based information, and then that is connected to smartphones or computers, and then translate or transmit that back to another human being. And then they have actually succeeded quite well. They were able to think about something and then put that into text information in a smartphone and actually send it to someone and then do the same way. And then they actually are working on, well, yeah, I mean, only challenge they're facing right now is that it works, but it's not as fast as human typing. So it's not being commercialized just yet. And of course, Google is also working on it. I mean, a lot of people talk about what is the next form factor after smartphones. Because whoever gets to own that form factor, whether that be VR, AR, or whatever people talk about, will probably be the next billion-dollar industry like dominator or something. So Google takes a very similar approach to Facebook. That's all I can say. But I'm just saying that these companies are working on telepathy research from the perspectives of also augmenting human intelligence with computational capability. Imagine if you can think and utilize your human brain at the speed of computational power. But what really strikes me is that this student at MIT Media Lab, where I'm currently at, he actually single-handedly beats both Facebook and Google from my perspectives. He's a master's student without any prior knowledge or extensive knowledge or research experience in neuroscience. But just by reading Wikipedia pages as well as like online references, he figured out that before we speak, the information inside the brain actually goes through your throat first. And then instead of reading out brain signals from the brain through the skull, he figured out a new form factor that actually reads out information from your throat. So he demonstrated, like in real life, that as he walks down the aisle of supermarket, he can actually look at it and think about, I want to buy this cereal, I want to buy this bread, and then actually be able to compute that in your smartphone and calculate, and then actually pay for it with your smartphone, even without speaking at all. And then he communicates back and forth with his machine next to his ear, which is actually also machine learning powered. So he doesn't have to speak or anything. He just has to think about it and be able to compute it, and then be able to exercise whatever actions. I mean, to me, this exactly achieves what Google and Facebook want to do, and beyond that. And then when he's playing chess, I mean, he has a whole 60 minutes, the US program, 60 minutes show on his technology, and then it's really impressive. And then I think he's currently deciding where to go in terms of, should I sell this company to Facebook or Google, or actually turn it into a nonprofit? But this is really impressive. And then after this, what concerned me was that, so we are at the stage where we can actually put on hardwares to our human body, human brain, be able to augment our intelligence. But at the same time, how do we make sure that the ethical and moral challenges of whatever we build as an AI system can actually be morally and ethically correct? When at the same time, if you have a machine connected to your brain, and what if your AI is smarter than you or overrides you or thinks faster than you, but makes morally incorrect decisions? So a lot of billionaires and thought leaders in this field have been thinking way hard about how do we bring ethical and moral concerns into AI development. And then these are some of my colleagues that are really at the forefront of thinking about it. Say, the person right next to Demis Hassabis of DeepMind is Professor Larry Lessig at Harvard Law School. He's an early founding father of internet regulations and laws and governance. And then he has a whole center called Berkman Klein Center, which is a combined project between MIT Media Lab and Harvard Law School, specifically addressing the ethical and moral challenges of the AI models we build. And Joey Ito on the far right also follows a similar route. And Reid Hoffman on the far top right is founder of LinkedIn, and he recently put in $1 billion to this nonprofit organization called OpenAI, which specifically works on this from industry perspectives, to be able to give industry or companies a second thought on actually, are you building a morally correct or ethically correct AIs, or how do you even define what is correct to begin with? So a lot of people are working on it. And then one of those, I guess, triggering moment that surfaced to me as this is an important issue is that there's another Media Lab student who, as a black woman, utilized some of the companies, some of the face recognition AIs that companies built, that Microsoft built, Face++, and Facebook and Google built, and then that are open sourced. And she tried to recognize herself with an image of herself. And then what ended up happening was that when she had Michelle Obama's younger photo there, the AI system basically said, this is male, young male, etc. Basically like gave wrong answers because these AI models are built with biased data or people who don't actively think about inclusion or diversity, probably. So she found out that basically, I mean, anyone could have found out, but she was really rigorously testing all these algorithms to be able to argue that some of these AI algorithms are actually racist to begin with. And then when she put on that white mask, the interface was correctly identifying her as a white male individual. And then recently she went to government to actually turn it into some sort of regulation to be able to actually watch for what companies build in terms of AI, because we're at this tipping point where AI systems can actually make decisions for you and recommend things for you. And then it's pretty scary that if these are inherently biased or ethically, morally challenged, then we should be mindful of that. And then can we trust companies on being the moral police officer on making the right decisions? Probably not. So it takes this concerted, organized, harmonious effort to be able to do this. And then I think there's a lot of interesting initiatives and energy coming out of both government and some of the academic institutions that I'm part of, including MIT Media Lab, that are actively addressing this. So as an example, Berkman Klein Center between MIT Media Lab and Harvard Law School are actively going through. So they have a lot of projects that both involve engineers and legal professionals or people in researchers in humanities to be able to really look at what is there a bias in resume search engines, or so that if certain people are getting jobs better and then is continuing to get favored in that way, then we need to be mindful of that. And then how do we actually moderate and filter different types of databases and then their correctness in terms of moral decisions that we can potentially make with AI models that end up being created. So yeah, I think AI augmented human intelligence is very imminent, and then it's going to be really exciting to me because I don't think I will be able to ever achieve human creativity in AI system anytime soon. But if we can actually charge human intelligence and including creativity with AI algorithms or technical capability, that will be a very exciting world. But at the same time, it concerns me a lot because it requires significant thoughts regarding how do we actually think about ethics and morals and philosophical views on what an AI system is or human intelligence is. And these are sort of things that engineers don't think about on a daily basis. So that's why as an MIT as a whole, I'm part of this initiative where we're trying to turn humanities and philosophy courses into a central component of everyone's studies. That's it.